Let's understand the design of 5G physical layer. Okay, in this video we'll go over different channels, signals, how the physical layer is designed on a very high level. And then going forward in this course we will understand all of them in very detail. So left to us there is this tower, okay, and these are the cell phones. So the goal is that we want to send data from mobile to tower or from cell tower to mobile. Okay, if it is from cell tower to mobile, it is downlink. It is called the downlink direction. If it is from mobile to cell tower, it is called uplink direction. Okay, now let's assume that we want to send a message. Okay, like this cell phone, one of the cell phone, it wants to send a text message, okay, that goes to some other device. So it has to first reach to the nearby cell tower. Okay, now here we will understand why do we need all different things that are there in physical layer and what are they. Okay, by understanding the flow of messages or the requirement to do the data transfer. Okay, so now let's take this cell tower. Let's see, there are 2-3 cells around us. Okay, this is the mobile, we'll call it UE, that wants to send the text message. Okay, now in order to send the text message, first it needs to find out, okay, which base station to connect. Okay, base station 1, 2, 3. Okay, it needs to find out whether to connect to this or this. Okay, and first before that it even needs to find out that, okay, if it wants to send the data through 5G, which of them supports 5G. Okay, for that there has to be some message transmitted. Okay, it needs to synchronize with these base stations. Okay, it needs to, in order to get the data or details of this base station transmitted signals, okay, it needs to get the data, decode it, and then find out. Okay, and in order to even decode the data, it needs to synchronize with the base station. That means both of them, base station and UE, should work at the same frequency first. Okay, and they should also be synchronized in time to decode the data. Okay, now to facilitate that, base stations should transmit some signal even without knowing that there is a cell phone out there. Okay, so these signals are called broadcast signals. So there has to be some broadcast signals continuously transmitted by base stations around even without knowing that there is a cell phone, to help someone out there a cell phone to connect, to decode, or to synchronize in time and frequency to get more details of that base station. Okay, these broadcast signals are known as PSS, SSS, PBCH. Okay, and there is one more called SIB1. Okay, so here these two signals here, PSS and SSS, are for time and frequency synchronization. Okay, they also help UE to decode the identity of the network. Okay, I mean that each base station have an identity. That identity is known as cell ID. Okay, so maybe we'd say that this base station 1 has ID 56, this base station 2 has ID, let's say 70, base station 3 has ID 51, and something like this. And the UE can decode this identity by decoding these broadcast signals. These broadcast signals should be designed in a way that they are continuously transmitted, okay, and it makes easier for a UE to decode them, okay, without having much detail. Okay, and then there is another signal called PBCH. This is physical broadcast channel. Okay, this contains some bare minimum information, okay, that that will help the mobile to decode the major chunk of data, or the information of the cell that is coming in this message. SIB1. SIB1 stands for System Information Block. System Information Block 1. Okay, this message contains the major details about the base station, and this particular message PBCH, this comes bundled with this PSS, SSS, PBCH. All three comes together. So these two will help in time frequency synchronization and also get the cell ID. PBCH will help to find out the location to decode this message SIB1 where we have most of the information. These are the broadcast data that has to be continuously transmitted by base station. Okay, see, our goal was to send a text message, okay, but we can't send a text message if we don't even know how to transmit it, how to send it. Okay, so the first thing that we need is having the broadcast signals from base station to the UE. Okay, now the UE can decode this broadcast information from multiple cells, and it can find out which cell to connect with. Okay, it can also decode signal energy and find out, okay, I am getting higher energy from this particular cell or from this particular tower, so I should be connected to this. Okay, let's say now it realized that I should try to attach or connect with this. Okay, I will use this cell tower to do my data transfer. Okay, so now UE knows about the base station. Okay, this is the base station now, but the base station does not know that there is a cell phone out there that wants to connect. Okay, and now the UE got synchronized that these are the time and frequency, but the base station does not know how far that UE is. Even the UE does not know how far it is from the base station. So to facilitate that, UE has to send a signal to the base station. The signal should be designed in a way that it can help base station to find out how far that particular UE is. Okay, and it can also help in synchronization. Okay, so now the UE, after decoding the broadcast information, it should send its first message this first message is known as PRAJ. Okay, this is a uplink message. This has to be sent from UE to base station. This will help base station to identify that, okay, there is a UE out there that wants to connect. Okay, so let's facilitate that. So there will be a group of message exchange after this PRAJ message transmission, that's called initial access. Okay, and this PRAJ signal should be designed in a way that first it can accommodate randomness because the base station does not know there is a UE out there. What if at the same time there are many UEs that wants to send the PRAJ? The base station does not know. Okay, and what if there is one UE very close and one UE very far? Okay, so the signal should be designed in a way that the base station is able to handle all different variations since it is the first signal. Okay, and it should also help base station to find out the distance. It can find out the distance from between the UE and the base station, and it can also signal UE that okay, you are like half a kilometer away, 100 meter away, or 5 kilometer away, so that from next time when you send the signals, you can prepone them, and then so that they are aligned with my boundaries. So here the thing is, the base station is the one that's common here. Okay, the UEs, it can have many UEs connected to it. Okay, so base station should be the one master here. Okay, what I mean is, since we have fixed resources, when I say resources, I mean time, frequency, and space. Okay, in these resources there has to be a connection between the base station, okay, and many cell phones, and the data transfer should happen. Okay, so this can only be done if there is a single uh, a person controlling it. Okay, and that is base station. Okay, since it is common and it is base station is the one that connects with all the cell phones. Okay, then the base station should be the one that decides, okay, when it should transmit data to a cell phone, and when a cell phone should transmit data back to the base station. Everything has to be controlled by base station. It has to be the master. It should tell UE that okay, you transmit at this particular time, you use this particular frequency resources or space resources to transmit a signal, and it should also control all the configurations of the data being transmitted in downlink and the data being transmitted in uplink. It should have control over everything because it has to manage many UEs connected to it. Okay, and allocate the resources wisely. Okay, so now we have seen that. Let's go back to our discussion. There is a base station, there is a UE, there is a broadcast data that has PSS, SSS, PBCH, SIB1. There is uplink data, first message, that is PRAJ. Okay, now see, our goal was to send a text message. Okay, now for any data that goes from a base station to UE or UE to base station, okay, this data goes through the channel called PDSCH in downlink and PUSCH in uplink. Okay, these particular channels, they carry the actual data that has to be exchanged between the base station and the UE. Okay, now in order to optimize this whole transmission, okay, that means let's take an example that base station wants to send a particular data or this particular channel PDSCH to UE. Okay, now there can be many different configurations of it. When I say configurations, I mean, let's say at an instant I want to send, let's say, only 24 bits. In another instant, let's say I want to send 1 lakh bits. Okay, now UE is close in one case, so I want to use very high modulation. Okay, let's say 256 com. Okay, in another case the UE is very far, I want to use a lower modulation, QPSK. Okay, in another case I want to use in the space different resources. That means in one case I want to use just one layer, in another case I want to use 4 layers. Okay, in one case I want to have different frequency resources or time resources. Okay, so there are lot many variations to transmit these shared channels, either PDSCH or PUSCH. Okay, so if you use a fixed pattern to transmit the data, that's not an optimized way. Okay, so we should account for all this and then transmit this PDSCH or PUSCH accordingly. Okay, now all these configurations has to be communicated to the receiver. The receiver should know about all the different variations in this configuration so that it can decode. So that configuration also has to be communicated to the receiver before the data is transmitted. Okay, so that means when a base station sends a PDSCH packet, it should also send the configuration before PDSCH. Okay, that goes through a different channel called PDCCH. Okay, PDCCH carries this configuration where PDSCH carries this data. Okay, so the receiver will first decode the PDCCH and it will find out these configurations, what configuration to apply, then it will decode PDSCH using that configuration. Okay, now the same is applied in the uplink also. Now in uplink, when the U is sending data, when the U is sending PUSCH, okay, since here base station is the master, okay, and U is a slave, so base station should communicate to UE what configuration to use, and that also goes through PDCCH. Okay, so base station will first send PDCCH that called physical downlink control channel. So we call this control data, control channel. Okay, this control channel contains these different configurations. UE will use this configuration and send the uplink data PUSCH. Now the base station already knows the configuration because it is the one that gave the configuration to the UE, so it will use that configuration and decode PUSCH data. Okay, so this is how the downlink control, that is PDCCH, downlink shared channel PDSCH, uplink shared channel PUSCH carries the data transfer. Okay, so now we have seen in the physical layer, we have seen PSS, SSS, PBCH, PDSCH, PUSCH, okay, and PRAJ, of course. Okay, now here the data transfer, okay, or the signal that we send, whether it is downlink or uplink, okay, it need not to be in a straight line, it is not a wired connection. Okay, the data or the signal will travel, okay, in many ways, okay, through multiple paths, okay, to reach to the receiver. Okay, now in this process, okay, the phase and amplitude may change, and that that will change, of course. Okay. Also, what if the U is moving? Okay. When the data transfer is happening, let's say you are on a bike or in a car or on a train, okay, and you are moving, you are coming closer, you are going away, or you are moving in any direction, does not matter. Okay. And the speed that which you are varying may also change. Okay, so that means the signal that is reaching to you and the path that the signal is taking is also changing. Okay. Now when the receiver is decoding the data, okay, that could be anything. It could be PBCS data it is decoding, it could be PDSCH it is decoding, it is in the uplink POSH it is decoding, whatever it is decoding. Okay, the detection of the signal, the decoding of the signal is possible only when we know some information about the channel. Okay, and if there are variations, like let's say I'm moving at a faster or a slower speed, or I'm at a different case, let's say I'm in a lift, I'm in a parking, or I'm inside in a room, for every different case the way signal reach from transmitter to receiver will change. And even if you don't move, the channel is changing. Okay, something in the environment is continuously moving, nothing is constant. Okay, so the receiver should also know some information about the channel, how the channel is changing the signal. Okay, so in order to facilitate that, so that the receiver is able to decode the data, the transmitter should send some reference signals, should be sent, okay, along with the data. Okay, so if you are sending PBCH, PDSCH, POSH, along with this data, there has to be some reference signals. Now the way we design the reference signals, or the way we assign it, may change based on the different scenarios like we discussed. Okay, but these reference signals will help the receiver to find out details about the channel, that how the channel has changed the signal, whether it has changed the phase, amplitude, or how fast it is changing and all. Okay, then the receiver will be able to apply the impact of that change and correct the derotate the signal, or correct it, and then try to decode it. Okay, so these signals are known as demodulation reference signals. Okay, so these signals are known as DMRS signals. Okay, they goes along with the data. Okay, so now these different channels and signals that we have seen, they are enough to do the data transfer. Now the text message that we wanted to send, we can send by using these different channels. Okay, one thing that we have still missed out of this, that is when we do the data transfer. Okay, let's say the base station sent a signal to UE. Okay, now there should be a way where the receiver sends a signal back to the base station telling about the packet loss or packet pass. Packet passed means it's decoded or it got lost. Okay, there has to be a way in which the receiver signals the transmitter, so that based on that, the transmitter may take an action, that if the packet has lost, so should I send it again, or if the packet has passed, then should I send a new packet. Okay, that decision should be taken based on the information provided by the receiver. Okay, we call it packet pass or loss, or we call it CRC information. Okay, this is facilitated by CRC, the cyclic redundancy check, that tells whether the packet passed or lost. Okay, so when it is a downlink data, Okay, for broadcast information, we don't need this packet pass or lost because the base station is continuously transmitting the same information. Okay, if you fail to decode one, you try the next. Okay, but for the actual data that you are sending, that is PDSCH or PUSCH. So for let's take one by one. For PDSCH, that goes from base station to UE, there has to be a message from UE to base station that conveys this information of the packet pass or fail. Okay, that information goes in an uplink control channel, PUCCH. You remember that downlink control channel is carrying the configuration for PDSCH and PUSCH both, where the PUCCH is carrying here the packet pass or loss information, also known as ACNAC of downlink of PDSCH. Okay, of course the PUCCH may carry other informations as well, okay, that we are not discussing right now, but it carries ACK and NAC for PDSCH that will help base station to find out what happened to the last packet and what should I do next. Okay, in case of PUSCH, when the UE is sending PUSCH, for this also there has to be a way for the base station to tell UE whether the packet passed or lost. So now this particular thing is facilitated in the PDCCH itself. Okay, since there is already a control data configuration is going, there is already control message going. So this particular information is also encoded in this message to tell UE about the CRC pass or fail, or the ACNAC of uplink is transmitted in PDCCH itself in some form, in some way. But for the downlink data, it goes through PUCCH. Okay, so now PUCCH also required to do the data transfer. Okay, so these are the different channels and signals we need to do the basic data transfer. Okay, now in 5G we can do better. Okay, we can optimize this whole process further. Okay, that means we can use many antennas, both at the transmitter, receiver, both at the base station or at the UE. Okay, we can do parallel data transmission. Okay, we need not to have only one antenna, one layer kind of a data transmission. By using multiple antennas, we can also direct our signal towards a particular UE. So that means we can form a beam, let's say towards this UE when you want to send data to this UE. We can do this, let's say here, or let's say here. Okay, so this way we can optimize our signal transmission further. Okay, we can, in the uplink also we can use multiple antennas. Okay, this using the multiple antennas helps us in many ways. One is we can transmit data parallelly, okay, to multiple UEs. Okay, like here we can transmit data to all three UEs at the same time. We can transmit multiple streams of data to single UE at the same time. Okay, like this is called like 4 layers of data, means 4 parallel streams being transmitted to single UE. Okay, and in the other case we can do it to multiple UEs. By using multiple antennas, we can also direct our signal towards a particular UE like we see here. Okay, now to facilitate this, okay, the transmitter, like here the base station, should know in which direction that UE is. What is the capability of that UE or that particular channel, whether this particular channel at this moment can support 4 parallel streams, or it supports only 2, or it supports only 1, what is the condition out there. Okay, the base station has to know this information in advance to facilitate this. Okay, so for this there has to be another type of a reference signals that tells us, that will first help UE to find out the conditions. Okay, the UE will find out that okay, right now at this moment the current channel that is between me and the base station can support two parallel streams, or it can also tell that okay, in this direction, okay, or this particular combination of antennas works best for me. Okay, that information it can decode based on decoding some reference signals that has to be transmitted by base station. These signals known as CSIRS signals. CSIRS signals is channel state information, as the name says. Channel state information reference signals are downlink signals transmitted from base station to UE. Similarly, there are signals for the same purpose transmitted from UE to base station. These signals are called SRS, sounding reference signals. Okay, they help base station to find out the channel between UE and base station for uplink signal transmissions. Okay, it finds out that okay, how many parallel streams that particular cell phone can send in uplink, and what resources works best for that particular UE. Okay, that information it can find out by decoding these signals, reference signals SRS, and downlink it can do by doing CSIRS. Okay, so the CSIRS and SRS are two different reference signals in downlink and uplink that will help us further optimize the data transfer. Okay, it can be done to for high throughput, or it can be doing the beam steering or parallel streams. Okay, so there are two more signals we'll add, CSIRS and SRS. Okay, so these are the physical layer channels and signals. Okay, now in 5G we have two different set of frequencies. One is sub 6, one is millimeter wave. Now in millimeter wave we use very high frequencies, okay, like 24 gigahertz to roughly 24 gigahertz to let's say 40 gigahertz roughly. These frequencies are being used. These are very high frequencies. Okay, so there is a possibility that the hardware may not perfectly generate, okay, those signals, and there is a possibility of having a phase noise in this signals generated. There is a possibility of having phase noise because of the hardware impurities. Okay, it can be both in the UE side or it can be a base station side. Okay, so if that is the case, if there is a phase noise, then the receiver may not be able to decode the data properly. So that in order to overcome this effect, if the receiver finds out this noise, okay, if the receiver can somehow finds out this phase noise, okay, like how much phase noise is there in the signal, so that it can correct it, so that it can decode the data. So it corrects the phase noise, and so that it can decode the data correctly, the same data that we are talking about, PDSCH, PUSCH and all. Okay, so for this there has to be again another reference signal should be designed in a way that can help the receiver to decode the phase noise, and then it can correct. So these signals are known PTRS signals. phase tracking reference signals. We need to track the phase of the signals and then apply it on the data and correct it. Okay, this particular signals, this particular reference signals is used in millimeter wave communication. Okay, so that reference signal also added to our list is PTRS. So now as you see, this is the complete picture of physical layer where we are supposed to send PDSH and POSH. This was our goal. These are the messages that carries the data. Everything else is an overhead, where if you see, these are synchronization signals. These are signals. This is also known as signals. This is reference signal. These are also reference signals. This is a broadcast channel. This is uplink control channel, and I think we left PDCCH. There is one more downlink control channel, PDCCH. Okay, so the goal was to send data PDSH and POSH. Okay, but in order to facilitate this, there has to be these many signals around. Okay, for the broadcast, for downlink control, for uplink control, for initial PRACH, initial access from the UE to base station, there has to be reference signals to find out the channel. There has to be reference signals for MIMO and all. There has to be reference signals for phase tracking. So all these signals and all control information, broadcast, everything is an overhead. It's known as overhead, where this PDSH and POSH carries the actual data. Now, apart from carrying the actual data that goes through, like from the application generated that we want to send, they can also carry the other informations, like informations related to about the base station or about the UE, the heavy messages that can be carried by this PDSH and POSH. Okay, so this is all about the physical layer, and this is all about the different channels and signals that exist in physical layer. And in this course, we'll understand each signal and channel into detail. We'll understand how these signals and channels are designed to facilitate what they are supposed to do. Okay, we'll go over the 3GPP specifications and see how these specs have been defined in the 3GPP, why they have been defined like this, and how the receiver will decode these signals. Okay, so this course is designed to understand these channels and signals that are part of physical layer. So this is all about the physical layer design. Thank you.